Hello, and welcome to this presentation on fractions. This is part 1 of a two-part lecture video related to the use of fractions. Within this presentation, we're going to consider some basic fraction terminology, such as numerator and denominator. We'll consider how to factor up fractions, how to factor down fractions. We will look at the process involved in converting a top-heavy fraction to a mixed number, and from a mixed number to a top-heavy fraction. We'll conclude with the addition and the subtraction of fractions. For reference, part 2 of the presentation considers multiplication and division of fractions, and also looks at applying the precedent rules to solving fraction problems. That's applying BODMAS. So let's define a fraction. The top line of a fraction is termed the numerator, and the bottom line of a fraction is termed the denominator. So the denominator, the bottom number, gives the fraction its name and also gives the number of equal parts into which the whole of the fraction has been divided. The numerator, that's the top number of the fraction, and gives the number of equal parts that are to be considered or to be taken. So for example, considering the circle on the left hand side here, it's broken into 4 parts, or 4 quarters, as we can see here. 3 of the parts are shaded and 1 is unshaded. So in fraction form, we would say that 3 upon 4 of the circle contain shaded parts, whereas there's only 1 part unshaded, so that's 1 upon 4 is an unshaded part. The value of a fraction remains unaltered if both the numerator, the top line, the denominator, the bottom line, are multiplied or divided by the same number. So consider multiplication here. If we're given a fraction 3 upon 4 and we multiply the numerator by 5 and we multiply the denominator by 5, then calculating we get 3 times 5 is 15 over 4 times 5 is 20. So we haven't affected the overall value of the fraction, we still have 3 quarters, but now we have it written as 15 over 20. So as long as we multiply the top and the bottom by the same number, we do not affect the fraction. It's just like multiplying the fraction by 1. So exercise 2.1, we're asked to write down the following fractions with the denominator stated. So in this case, for question 1, we're given a fraction of 3 upon 4, but the denominator at the moment is 4. We're asked to now change the denominator to be 28. So if I undertake this calculation here, we would have 3 upon 4 as the fraction. We now want to make the denominator 28 here. So what do I multiply 4 by to get 28? I multiply the 4 by the 7. So to keep the fraction the same, I must then multiply the top by 7 also. So 3 times 7 is 21. So 21 upon 28 is the same as 3 upon 4. Question 2, I'm given a fraction of 3 divided by 5. And I've been asked to make the denominator in this case 20. So 20 here. So again, what do I multiply 5 by to get 20? I multiply 5 by 4. So I need to multiply the top by 4 to ensure I don't affect the fraction. So 4 times 3 is 12. So 3 upon 5 is the same as 12 upon 20. I would suggest you stop the presentation and attempt questions 3 through to 8, but the answers are shown on the following slide. Exercise 2.1, here are the answers to the questions on the previous slide. This slide has been included for reference, and it's sometimes useful when you're dividing numbers to be able to understand whether 3 divides into the number completely, 4 divides into completely, etc. So these are some tips and wrinkles here. So a number is divisible by, so consider 2, if it's an even number. All even numbers are divisible by 2. A number is divisible by 3 if the sum of all the digits is divisible by 3. So in other words, taking a number 1365, if we were to add the 4 digits together, 1 add 3 add 6 add 5, that gives us 15, and 15 is exactly divisible by 3. So as long as the numbers, when added, become a number divisible by 3, then we can divide the entire number by 3. A number is divisible by 4 if the last two figures are divisible by 4. So in the number 2148, the last two numbers 4 and 8 are both divisible by 4. So therefore the entire number is divisible by 4. A number is divisible by 5 if the last figure is a 0 or a 5. So for example, 4260 can be divided by 5, and also 8925 can be divided by 5. They're both exactly divisible by 5. And finally, a number can be divided by 10 if the last figure in the number is a 0. So 50,470 is exactly divisible by 10. This has just been included for reference, but it might be useful later on when we're undertaking addition and subtraction of fractions and we're trying to find what's called a common denominator. Exercise 2.2. In this exercise we're asked to reduce the following fractions to their lowest terms. So in exercise 1 we were factoring up the denominator and appropriately factoring up the numerator. Now we're going to reduce the fractions given by dividing the numerator and denominator by the same number. So for example, we've got 8 divided by 16. So if we divide the numerator by 8, we will get 1. If we divide the denominator by 8, we will get 2. So we could reduce 8 upon 16 to 1 upon 2, or half. Question 2, we've got 9 over 15. Using our little hint, 1 plus 5 is 6, so 6 divides by 3, so we can divide 15 by 3, and of course we can divide 9 by 3. So dividing the numerator by 3, we will get 9 divided by 3 is 3, and dividing the denominator 15 by 3, we will get 5. So we end up with 3 upon 5. So 9 upon 15 can be written as 3 upon 5. I would encourage you to stop the presentation and try and attempt questions 3 through to 10. We're trying to reduce each of these fractions to their lowest terms. Again, referring to the reference information on the previous slide, that may help you to determine what numbers to divide the numerator and denominator by. Exercise 2.2, here are the answers for questions 1 through to 10. Another definition for us here. The lowest common multiple, sometimes denoted as LCM, of a set of numbers is the smallest number into which each of the numbers of this set will divide exactly. So for example, the lowest common multiple of the numbers 4, 8, 10 and 20 would actually be 40. The LCM is 40. That's the lowest number they completely divide into. 4 divides into 40 10 times, 8 divides into 45 times, 10 into 44 times, and 20 into 40 twice. If we want to compare values of fractions which have different denominators, we need to express all the fractions in the lowest common denominator, LCD. And then we can compare the numerators of the fractions to see which is the smallest, which is the largest fraction. So from the previous slide, we found the lowest common multiple of the numbers 4, 8, 10 and 20. In this particular case, these are the denominators of the fraction shown. So we would classify 40 as the lowest common denominator. It's the lowest common multiple of 4, 8, 10 and 20, but it's the lowest common denominator of the fraction shown. So what we're going to do now is factor each of the fractions up to make the denominator 40, and then we'll be able to compare them to find which is the largest and which is the smallest. So considering the fraction of 3 upon 4, I need to make the denominator 40. So to make the denominator 40, I will need to multiply the top and bottom by a factor of 10, which I'm doing here. So 3 times 10 is 30, and 4 times 10 is 40. Consider the next fraction, we've got 5 divided by 8. Again, I've got to make the 8 on the bottom a 40. What do I need to do to make it 40? I need to multiply it by a factor of 5. So of course I must multiply the top by 5. so it doesn't affect the fraction. So on the top line, 5 times 5 is 25. On the bottom, 8 times 5 is 40. Consider the next fraction. I have 7 upon 10 given above. Got to make the 10 in the denominator at 40s, so I multiply that by 4 in the bottom, and of course 4 on the top. So on the top, 7 multiplied by 4 is 28. On the bottom, 10 multiplied by 4 is 40. And finally, I was given a fraction of 11 upon 20. And again, I've got to make the denominator 40, so I need to multiply the denominator by 2, and then so multiply the numerator by 2. So 11 multiplied by 2 is 22, and 20 multiplied by 2 is 40. So there are my three fractions. So now I can easily compare them because the denominators are the same. So we can see the smallest fraction in this case is the 22 upon 40, or in other words the 11 upon 20. And the largest fraction is the 30 upon 40, or of course that's the 3 upon 4. We've got some more terminology here. Proper fractions. A fraction such as 6 divided by 7, or 6/7, in which the numerator is smaller than the denominator, that's termed a proper fraction. So any fraction that has its numerator smaller value than the denominator is called a proper fraction. Alternatively, we could have something called an improper fraction, or a top-heavy fraction, or even I've seen them termed vulgar fractions. So fractions such as 17 upon 12, or negative 115 upon 22, where the numerator is greater than the denominator, is called an improper or top-heavy fraction. Improper fractions can be reduced to what are termed a mixed number, where a mixed number is a whole number and a proper fraction. And we'll consider mixed numbers on the following slides. So a mixed number has an integer part and a fractional part, and can be obtained from an improper fraction by division. So for example, if we were given the improper fraction of 7 divided by 3, so what we do first of all is divide the 7 by 3 and see how many times it completely divides into 7. Well, 3 divided into 7 twice, but with what's called one remainder, one remaining item. So we could write that as 2 and 1/3, which is a mixed number. The 2 is the integer and the 1 upon 3 is the proper fraction. Here's another illustration. We've got an improper fraction of 27 divided by 4. We've got to write that as a mixed number. I think I'll work it through down here. So 27 divided by 4, that's the fraction. First thing we do is say, how many times does 4 divide completely into 27? Well, from our tables, hopefully you know that 6 4s are 24. So it will go completely 6 times, which would be 24. But we've got 27 here. So we have 3 parts remaining. And we normally write that over the denominator. So 3 upon 4. So 27 upon 4 could be written as 6 3/4. Example 1b here, we're given the improper fraction of 175 divided by 15. Initially what I'm going to do here is cancel down by 5 by dividing top and bottom by 5, just simplify my numbers, and then I'll undertake the division process. I think I'll write example 1b below for completeness. 175 divided by 15 is the top-heavy fraction, or the improper fraction we're given. Because the numerator and denominator values end in 5, we know we can divide completely by 5. So divide the denominator by 5, 15 divided by 5 is 3, and divide the numerator by 5, 5's in 175, go 35 times. So we can now write this top-heavy fraction as 35 divided by 3. Now I'm going to write this top-heavy fraction in terms of a mixed number. So how many times does 3 divide completely into 35? It goes 11 times. 11 3s are 33. So we have 2 remainders. So that's 2/3 remainder. So there's our conversion from the improper fraction given in the question to the mixed number. Example 1c, we're given a more complicated fraction here. It's actually negative, but that doesn't really bother us. Negative 151 divided by 21. We've got to write this as a mixed number. I cannot divide the 151 or the 21 by any particular whole number to reduce the fraction, so I'm going to have to actually do the division sum. So my mixed number now becomes negative 7 and 4 over 21. Here's exercise 1A for you to attempt. In part 1, we're asked to write the improper fraction of 37 divided by 4 as a mixed number. And in part 2, we're asked to write the improper fraction of negative 135 divided by 4 as a mixed number. The answers are shown in the brackets on the right hand side. I would encourage you to stop the presentation and undertake this exercise, but the work solutions are shown on the following slide. Here are the work solutions. Exercise 1A part 1. We're given 37 upon 4 for our improper fraction. We have to write that as a mixed number here. So how many times does 4 divide completely into 37? Well, 9 4s are 36, so that will be 9 and 1 remaining, so 9 1/4. Our solution for the first question. And in question 2, the improper fraction now is negative 135 upon 4. The negative doesn't really bother us, the sign of the fraction. And again, how many times does 4 divide into 135? So from my long division calculation on the right hand side, I find that 4 divides into 135 completely 33 times, so it's been negative 33, and the remainder is 3, so that would be written as 3 over 4. Now we're going to reverse the process. We're going to convert mixed numbers into top-heavy fractions here. So the reverse process can be applied. So the mixed number now can be changed to an improper fraction, a top-heavy fraction, by multiplication. Example 1b here, we're given 6 3/4. We've got to put that in terms of the quarters, that's the denominator here. So how many quarters are there in 6 whole numbers? Well, that would be 6 multiplied by 4. We've got to add to that the 3 from the 3/4, and that's all, of course, divided by the denominator, which is 4. So 6 times 4 is 24, add 3, that gives us 27 upon 4. So 6 3/4 is the same as 27 upon 4. Another example, we've got 11 2/3 here. So in other words, we've got 11, if you divide that into thirds, that would be basically 11 multiplied by 3. So there's my 11 multiplied by 3 here. And I add my 2/3, and that's all over the third here. So calculating, and what's your BODMAS here? You've got to work out the 11 multiplied by 3 first of all. So 11 multiplied by 3 is 33. Add my 2, gives me 35 upon 3. Notice I didn't actually have the brackets around the second example here, but I didn't really need them if I follow my BODMAS rules, because I got to the multiplication before I do the addition. So the 11 multiplied by 3 and then add 2. Just be careful with your BODMAS there. Exercise 1b, we're asked to change the following mixed numbers into top-heavy fractions. We're given 4 questions here. First one 7 1/4, second one 33 1/3, third one 16 4/11, and the fourth one 10 11/15. I would encourage you to stop the presentation and attempt these 4 little questions here. The answers are shown in the brackets on the right hand side. The work solutions are shown on the following slide. So here are the work solutions for exercise 1b. Part 1, we're given 7 1/4 for our mixed number. We've got to put that into a top-heavy fraction. So that's equal to 7 multiplied by 4, add the 1, and that's all divided by 4. Again, be careful of your BODMAS here. 7 multiplied by 4 is 28, add 1 is 29, and divided by 4. Part 2 here, we're given the mixed number of 33 1/3. We've got to write that as a top-heavy fraction. So the denominator will be the 3. On the top line I will get 33 multiplied by 3. Again, I add 1 in this case. That's equal to 33 multiplied by 3 is 99, add 1 is 100. That's divided by 3. Part 3, we're given 16 and 4/11. So that's equal to 16 multiplied by 11. That will be 176. Add 4, 180. And we divide that by 11. Finally, part 4, we're given 10 and 11/15. Got to write that as a top-heavy fraction. On the top line, that will be 10 multiplied by 15, and we add 11. Evaluating the top line, 10 multiplied by 15 is 150, add 11, 161, so it's 161, and that's divided by 15. So in this case we've converted the mixed numbers to top-heavy fractions. I'll leave you with exercise 2.3. Again, you've got to take the mixed numbers given and write them as top-heavy fractions. There are 5 questions shown here. The answers are shown below. Exercise 2.4. We're asked to arrange the following sets of fractions in order of size, beginning with the smallest number. So what we find here is each of the fractions has a different denominator, so we'll have to find the lowest common denominator, and we'll have to write all the fractions in terms of the lowest common denominator and arrange them in order. I'd encourage you to start the presentation and attempt this exercise. It's good practice in finding the lowest common denominator and also factoring up fractions. So just showing you a few word solutions here to question 1. The lowest common multiple of 2, 6, 3 and 12 will be 12. 2 divides into 12, 6 divides into 12 and 3 divides into 12 completely. So 12 will be our lowest common denominator. So now I need to factor up the various terms so that they reside over a denominator of 12. So taking the first term of a half, I need to multiply top and bottom by 6 here, so I will get 6 over 12. Taking the second fraction, 5 upon 6, I need to multiply top and bottom by 2 here. So that becomes 10 upon 12. Taking the third fraction, 2 upon 3, I need to multiply top and bottom by 4 here. So that becomes 8 over 12. And the last fraction is obviously written over 12. So write them in order. This would be the first fraction, this would be the second fraction, this would be the third fraction, and this would be the fourth fraction. That's what the question wants you to do, write them in order. So that was a denominator of 12 here. We'll just work through question 2. This is more difficult to find the common denominator here. What we can sometimes do is multiply 2 of the denominators together and see if that helps us. So we could multiply 10 by 4 to give us 40, but 7 doesn't divide into 40. We could multiply the 4 multiplied by 7, that would give us 28, but 8 doesn't divide into 28 and nor does 10. We could multiply, say, the 7 by the 8, get 56, but 10 doesn't divide into 56. So very difficult to find a number here. What I think I will use is actually the 10 multiplied by 4 multiplied by 7, because that will give us 280, and 8 divides into 280. We need to now use it as the common denominator. So for the first fraction, to make the denominator and denominator, got to multiply top and bottom by 28. So 9 multiplied by 28 is 252 divided by 280. Considering the second fraction, denominator is 4. I've got to multiply that by 70 to get 280. So I've got to multiply top and bottom by 70. So 3 times 70 is 210, and I'm dividing that by 280. Third fraction is 6 upon 7. I've got to multiply the 7 by 40 to get 280 as a denominator, so I need to multiply top and bottom by 40. So I get 240 divided by 280. The final fraction of 7 upon 8, I need to multiply 8 by 35 to get 280 on the bottom, so multiplying top and bottom by 35. I have 245 on the top line divided by 280 on the bottom line. Again, it's easy now to see the ranking order. This is the smallest term, so that would be number 1. This is the next term, number 2. Next term, number 3. And this is the largest term, number 4. I will let you work through questions 3, 4, 5 and 6, so there is a hint in the question below that might help you. Now we're going to consider adding and subtracting fractions. To do this, we want to express each of the fractions we're given in their lowest common denominator, and then we're going to add or subtract the resulting numerators. So in example 1e shown here, this is an addition of fractions. We've got 2 upon 5 and we're adding to that 1 upon 5. Because the denominators are the same, this is very easy. We simply add up the numerators. So 2 plus the 1 is 3 upon 5. So when the denominators are the same, we simply add the numerators. Example 2e considers subtraction of fractions. We're given 5 upon 7 and we're subtracting from that 1 upon 7. Again, as the denominators are the same, we simply subtract the numerators. So it's simply 5 subtract the 1 all over 7, so that's 4 upon 7. Example 2e shows a problem where the denominators are different. We've now got 1 upon 2 and we're subtracting from that 9 upon 14. First thing we need to do, as we did on the previous exercise, is to have a common denominator. In this case, the lowest common denominator is 14. 2 divides into 14, obviously 14 divides into 14. So that's my common denominator. What I'm effectively doing now is writing both of the numerators over the common denominator of 14. So how many times does 2 divide into 14? We know it goes 7 times, so I'm going to multiply the 1 here by 7. Taking my next fraction, how many times does the 14 divide into the 14? Because once, of course. So I'm going to multiply my 9 by 1. And I'm subtracting here, of course. So now I've got my common denominator. I can simply subtract the numerators. 7 minus my 9. So I end up with negative 2 in this case upon 14. But of course that will cancel down now to negative 1 upon 7. And just for your reference, notice that the way I've written this expression here is really the same as writing this expression here. Just a different way of showing the fractions. I'm showing here the common denominator of 14 for both fractions. So example 3 highlights a slight complication you've got when you add in fractions that have different denominators. You have to find the common denominator first of all, and then write all the fractions effectively over that denominator, in whichever format you prefer to use. Exercise 2.5, we're asked to add up the various fractions, questions 1 through to question 12. Sometimes we have 2 fractions to add, and later on we actually have 3 or even 4 fractions to add, but the same procedure is required in all questions. You've got to find the common denominator first of all, and if it helps you, where you have whole numbers given, you can simply write that as 3 over 1 shown here, or 3 over 1 shown here, and 2 over 1 shown here. If that helps you, you can write them in that fraction format. I would encourage you to start the presentation, attempt these questions now, but some of the questions are worked through on the following slides. So question 1, we're asked to add a half to a third. So the common denominator will be 6 in this particular case. 2 multiplied by 3 gives you the common denominator. So I'm going to write it in this format. I'm going to write my common denominator here of 6. And I will say how many times does 2 divide into 6? It goes 3 times exactly. So I multiply the 1 by 3 on the top line. I'm adding the fraction, so it's an add here. Then I say how many times does 3 divide into 6? That goes twice completely, so I multiply the 1 by 2 on the top line. Evaluating the top line, so that becomes 3 plus 2, that becomes 5 over 6. Question 4, we've got 3 upon 10, add to 1 upon 4. So we could multiply the 10 by the 4 to get 40. That is a denominator, but it's not the lowest one, because 10 and 40 actually divide completely into 20. So I'm going to use 20 as my lowest common denominator here. Again, my procedure is how many times does 10 divide into 20? It goes twice, so I multiply the 3 by 2, and I'm adding again in this case. How many times does 4 divide into 20? It goes 5 times, so I multiply the 1 by 5. Evaluating the top line, that becomes 6 plus 5, that gives me 11 over 20. Question 7, I'm asked to add 11 upon 8 to 57 upon 16. Again, I need a common denominator. The common denominator here would be 16. Both 8 and 16 divide completely into 16, so we're going to do 16. 8 divides into 16 twice, so that becomes 11 multiplied by 2 on the top line, and I'm adding to that. 16 divides into 16 once, that's 1 times 57, that becomes 57 on the top line. Evaluate the numerator, 57 plus 22 will be 79, so it's 79 over 16. In question 10, we're asked to add 9 upon 2 to 3 upon 1. Notice I add the 1 here just to show the formatting of the denominator. 2, 1 upon 3. Work through this down here. So the common denominator in this case will be 6, because 2, 1 and 3 divide completely into 6. That's my common denominator. How many times does 2 divide into 6? It goes 3 times, so I have 9 multiplied by 3. And I'm adding to that. How many times does 1 divide into 6? And that goes 6 times, so that becomes 3 multiplied by 6. And how many times does 3 divide into 6? It goes twice, so that becomes 1 multiplied by 2. So there's my numerator. Evaluating the top line, I will get 27, add to 18, add to 2, it's all divided by 6. And evaluating the top line, that becomes 47 upon 6. I'll leave you to work through the remaining questions shown here. The answers are stated on the following slide. Exercise 2.5, here are the answers for questions 1 through to question 12. Now we're going to consider subtraction of fractions. Exercise 2.6 asks us to simplify the following fractions, and they all relate to subtracting one fraction from another. So question 1, we've got a half, this time we're subtracting from that third. There are 9 questions here. Again, I would encourage you to stop the presentation and attempt these questions. The answers are shown below in the table. Some of the questions are worked through on the following slides. So here's a few worked solutions for exercise 2.6. Question 1, we've got a half subtract the third. Again, we look for a common denominator, which in this case will be 6. How many times does 2 divide into 6? That goes 3 times, so that's 3 times 1 is 3 on the top line. How many times does 3 divide into 6? That goes twice, so that will become 2 times 1 on the top line. And don't forget, this time we're subtracting the fractions. So we're subtracting the fractions, we subtract the numerator values. So that's equal to 1 upon 6. In question 2, we've got a third, take away the fifth. So the lowest common denominator for 3 and 5 is 15. How many times does 3 divide into 15? It goes 5 times, so 5 times 1 is 5 on the top line, and we're subtracting from that. How many times does 5 divide into 15? That goes 3 times, so 1 times 3 is 3. So 5 subtract 3, that becomes 2 upon 15. Question 4, we've got 7 eighths, subtract 3 eighths. Now because the denominator is the same, this makes the sum very easy. They both have the same denominator of 8, so it's simply going to be 7 subtract 3 in the numerator, so that will become 4 upon 8. And don't forget, we can cancel that down to its simplest terms. That's actually a half, or 1 upon 2. Question 7, we've got 3 upon 1, subtract 5 upon 7. So the common denominator here would be 7. How many times does 1 divide into 7? That's 7 times, so that becomes 3 multiplied by 7 on the top line. And we're subtracting from that. How many times does 7 go into 7? That's once, so that's 5 on the top line. So evaluating, that's 21, subtract 5, that gives us 16 upon 7. Notice in the answers here they've written it also in terms of a mixed number, which you could do if you want to. That would be 2 and 2/7. I'll leave you to solve the rest of the questions. The answers are shown in the table. Now we're going to consider addition and subtraction of fractions. Exercise 2.7, we're asked to simplify the following. The only thing that's different here is we've got the addition and the subtraction in the same question. So very similar process as in the previous questions. You just got to find the common denominator and then you add or subtract the numerators as the question states. I would encourage you to stop the presentation and attempt these questions. The answers are shown on the following slide and a few word solutions also shown. So in question 1 we've got 5 upon 2 added to 1 upon 4 and we're subtracting from that 3 upon 8. As with all addition and subtraction problems, we have to find a common denominator. So looking at the numbers 2, 4 and 8, the lowest common multiple there would be 8. They all divide into 8. So 8 is our common denominator for this sum. And again, going through our process, how many times does 2 divide into 8? It goes 4 times, so that becomes 5 multiplied by 4. And taking the second fraction, how many times does 4 divide into 8? That's twice, so that's going to be add 1 multiplied by 2. Looking at the third fraction, which is denominator of 8, 8 into 8 goes once, so that on the top will be subtract 1 multiplied by 3. Note here that we're adding the first two fractions, so there's my addition sign, and we're subtracting the last fraction there. Evaluating, we get 20, add 2, and we're taking away 3, so that's going to be 19 over 8. Or as a mixed number, it evaluates to 2 and 3/8. Question 3, we've got 3 upon 8, subtract 5 upon 2, subtract 5 upon 1. Common multiple of 8, 2 and 1 is going to be 8. So our common denominator here will be 8. How many times does 8 go into 8 is 1, so that's 3 multiplied by 1. We're subtracting, and how many times does 2 go into 8? That's 4 times, so that becomes 5 multiplied by 4. And 1 into 8 goes 8, so that's going to be subtract, in this case 5 multiplied by 8. Evaluate, that becomes minus 57 divided by 8. In question 5 we've got a half added to a third, we're subtracting a quarter, subtracting a fifth. Again we have to find a common denominator for all of these terms. So what do they all go into? Well, if we multiply 2 by 3 is 6, obviously 5 doesn't go into 6. Multiply 2 by 3 by 4, that would be 24, but 5 doesn't go into 24. So we try multiplying 3 by 4 is 12, multiplied by 5 would be 60. So yes, they would all go into 60. So I think 60 is going to be the lowest number we can use here. So 60 will be the lowest common denominator for all these terms. Back to our process, how many times does 2 divide into 60? That goes 30 times, so that will be 1 times 30 on the top, so 30. Add into that. 3 is in the 60 goes 20 times, so 1 times 20 is 20. Then we'll be subtracting from that. 4 is in the 60 goes 15 times, so 1 times 15 is 15. Subtract the 15. And then 5 in the 60 goes 12, so we'll end up subtracting 12. Evaluating, that becomes 23 divided by 60. I will leave you to solve the rest of the solutions. Don't forget the 10 in this case is divided by 1 if that helps you. Over here the 7 is divided by 1, 6 is divided by 1, and the 4 and the 7 also divided by 1, if that helps you to keep your formatting. The answers to the question are shown on the following slide. Exercise 2.7, here are the answers for question 1 through to question 8. Here's the bibliography used to help generate the presentation. Some long-standing engineering maths textbooks, very good books here. We've now come to the end of part 1 of the fractions lecture. There is a separate presentation relating to part 2 of the lecture where we review fraction problems involving multiplication, division and also the precedent rules, i.e. use of BODMAS within fraction calculations. I would strongly encourage you to review that presentation and so complete our fractions lecture. Thank you for viewing.